So today we are going to be talking about Elasticsearch. Elasticsearch is a search and analytics engine that allows you to store, search, and analyze big volumes of data quickly. Overall, it is easy to use, has a great community, and has a bunch of broad use cases. So to start off, each instance of Elasticsearch is called a node. Each node has a unique ID and a name. When you start up a node, a cluster is formed automatically. There can be one to many nodes in a cluster, and these nodes are distributed across different machines, while all belong to the same cluster and work together to accomplish a task. Now, this can be seen kind of as a group project where each member of the group is assigned a specific role, but everyone is working together to accomplish an overall task. Nodes are assigned one or more roles within this cluster, including holding data. This data is stored as a document, which is a JSON object that contains whatever data you want to store in Elasticsearch. Documents that share similar traits and are logically related to each other are grouped into an index. This is helpful because it allows for us to know where to find certain information. For example, here we have a cluster of nodes, and if we're looking specifically at a bunch of data from our grocery store, we have a produce index and a dairy index. Now in here, we could have data pertaining to apples and oranges and broccoli. And in the dairy index, we could have data pertaining to milk and cheeses. It's important to note that the index is not actually storing documents. It just keeps track of where documents are stored. What actually holds data is called a shard, and this is where you run a search. An index will come with a default shard, which is shown here, but an index can have multiple shards that are distributed across nodes. You can add more shards and nodes as the need arises when there's an increase in data, and this can overall speed up your search. For example, let's say you were looking for a specific piece of data in one shard that had 100,000 data entries. Now, it might be difficult to find that one piece of data out of 100,000 and take quite a bit of time. So by adding 9 more shards and nodes, you can split up this 100,000 to where each shard is only searching through 10,000 entries all at the same time. Overall, this would make the search much faster because it is splitting up the work. To avoid further issues, if a problem occurs, such as a specific node going down, we can make copies of the original shards and store these copies across different nodes. These are called replica shards. So for example, R0 is a replica shard of P0, and R1 is a replica shard of P1. So if one node, for example, P0 were to go down, we would be okay because we have the replica shard R0. Replica shards also improve the performance of your search because when there are large amounts of data, the primary shards might have trouble keeping up with the high demand. The replica shards can help out and better handle increased demand on search. So here we have just an overview of everything I've kind of talked about, laid out into the key components.
For Elasticsearch, there are 3 main categories of use cases. Number 1, there's main data store. Elasticsearch is used for creating a searchable catalog, document storage, and a logging system. Number 2, Elasticsearch is used with complementary technology. Elasticsearch can be used to add visualization capabilities to SQL, MongoDB, cast indexing, and search or add processing and storage. And then number 3, additive technology. If you already have logs in Elasticsearch, you can add metrics, monitoring, and analytic capabilities. So the first use case that we're going to take a look at is Netflix. The Netflix messaging system uses Elasticsearch behind the scenes to keep track of their message lifecycle. The messages they send are divided into 4 different categories. First, there's the message you receive when you join Netflix. Then there's the messages that Netflix members receive about content that they might like or about new features. Third, there's the more engaging and personalized messages that are sent after Netflix learns more about each of their users. And then 4, when users leave Netflix, the message that they send about how to rejoin. So each status message is recorded on Elasticsearch, and the proper team is able to filter each category by writing a query on Kibana. So let's say that a new movie has just been added to Netflix and a message is sent to all current users about the new movie. Using Kibana, Netflix is able to see in real time how many people get notified with the new message and the message delivery success rate. They are also able to verify the reason why some of the messages have failed, which has introduced the ability to investigate and tackle issues much faster. So a specific example of how Elasticsearch came in handy was how Netflix was able to quickly and efficiently solve a problem of mass message failures in Brazil in 2012. By using a pie chart in Kibana, Netflix was able to find immediately a huge amount of invalid memberships failures. It was because of Elasticsearch that Netflix was able to discover and fix these failures in real time. Okay, so next we're going to take a look at how Tinder uses Elasticsearch. Tinder is an example of a mutual collaboration between a big tech company and Elasticsearch. Tinder is a search engine with double digit events, hundreds of countries, and more than 50 languages. Most user interactions on Tinder trigger an Elasticsearch query. The queries in Tinder are very complex and must be personalized, location-based, bidirectional, and in real time. The job of Elasticsearch is to make the different components on the back end, such as data science, machine learning, bidirectional ranking, and geolocation, all work together efficiently for the user experience. So an explanation, machine learning algorithms are personalized and used in this context. Location-based would mean that a match based on where you are at a certain point in time. Bidirectional would mean to know which users will swipe right on each other, which basically means a match. In real time, the entire interaction has to happen within milliseconds from a massive amount of users and with many variables associated with each of them. So performance is a hurdle in this situation, and that is why Tinder is cooperating with the Elasticsearch team to fine-tune many parameters and to solve bugs. Tinder has been supporting the Elasticsearch community to help improve the overall Elastic Stack product, as well as to improve the experience for the Tinder user themselves. So Tinder is an example of a large company that uses Elasticsearch, but is also collaborating with them to improve Elasticsearch as well. And then the third example we're going to take a look at is the use case of Cisco Commerce Delivery Platform. They switched from RDBMS, which is a relational database management system, to Elasticsearch in 2017 when they upgraded their commercial platform for the following reasons: to add fault tolerance working in active mode, rank-based and type-ahead search for data source from multiple databases on 30-40 attributes to get sub-second results, and global search. If no specific objects are specified in your search, the search engine will find results against multiple objects. So this is for Cisco Commerce Delivery Platform, and their threat intelligence department is what is keeping malware and spams from oversaturating the internet. In the Cisco department, they view more than 1.5 million malware samples on a daily basis. So it's because of this just sheer volume that Elasticsearch is helpful with the search capabilities. And then some other use cases and industrial adaptations. So first, we have logging and log analysis. The ecosystem built up around Elasticsearch has made it one of the easiest to implement and scale logging solutions. Elasticsearch gives you plenty of options for grabbing data and getting it indexed. Next, we have scraping and combining public data. The lack of a strict schema gives Elasticsearch the flexibility to take in multiple different sources of data and to still keep it manageable and searchable. Third, we have full text search. Elasticsearch's search capabilities are powerful, flexible, and include a great number of tools to make search easier. Elasticsearch has its own query DSL as well as built-in capabilities for autocomplete. We have event data and metrics. Elasticsearch operates really well on time series data like metrics and application events. Elasticsearch has the components to grab metrics and events no matter what technologies you use. And fifth, we have visualizing data. Kibana is a very powerful and easy to use visualization tool, which we will talk a little bit more about later. There are tons of charting options, a tile service for geodata, and timeline for time series data. So some specific use cases and industrial adaptations. We have Uber. Elasticsearch plays a key role in Uber's marketplace dynamics core data system, aggregating business metrics to control critical marketplace behaviors in real time. Examples are dynamic search pricing, supply positioning, and to assess overall marketplace diagnostics. We have Yelp, which I'm sure you've heard of Yelp. They use queries to search large amounts of data with several different parameters quickly and efficiently. We have Slack, which we use for this class. Slack monitors for malicious activity and handles the resulting alerts using centralized logging to handle data from thousands of hosts, and they do this by using Elasticsearch. And then we have Walmart, specifically Walmart Technology. They protect their customers from scams by identifying instances of fraud in real time with the Elastic Stack.
Hey, so like anything, Elasticsearch has strengths and of course weaknesses. So to start off, one of Elasticsearch's main strengths or main selling points, it seems like, is its scalability. Unlike some other database management systems, Elasticsearch is extremely good at using an extremely large volume of data in a short amount of time. This is usually done by sharding, which I recommend you look up because it's pretty interesting in clustering. Next is multi-language support. Since it's a fairly new database management system, it is able to support a wide variety of languages without the help of community-made tools, unlike some other DBMSs. The next thing is high performance. It is tied to scalability somewhat, but since Elasticsearch is able to take in that much data, or a large volume of data, it's not only able to finish it quickly, but Elasticsearch allows it where you can execute almost every process for that data and stuff in real time, which is really good. The final thing is aggregation, or the ability to do it. And what aggregation is basically like you have a set of data and you can put all that stuff into a group, or some data into a certain group and all that stuff. So Elasticsearch has made it where it's really easy to do. And it's also extremely customizable and stuff. Now, onto the limitations. It seems like it's a pretty good thing, but it's also fairly new. So it has some not limitation, but like things it needs to work on since it is fairly new. So first is it doesn't support SQL like joins. Of course, since it's not SQL or anything like MySQL, it's not going to be able to support that stuff, which can be hard to grasp since anyone that's learned MySQL is used to that. So instead of using joining tables or join to join tables, they'll use parent-child nesting to handle relations. Next thing is that the updates tend to be expensive since instead of like rewriting that, or not rewriting, instead of updating the file, it deletes the old document and then it recreates a new one, which could take up a lot more storage and just processing power in general. And the final thing, which in my opinion is a biggie, is that rollbacks are not supported. So if you update that file or just update Elasticsearch and you realize either that update is extremely buggy or you just do not like it for some reason, that's it. You can't go back. You can't reverse it unless you like copy the data and put it into another older file and all that stuff. Which is one thing that they did think of when they were making it, was they gave you control of what version you want to choose. So you don't know if the next version or the updated version is good, so you might have to wait. So you don't have to update like automatically when it comes out. So now ElasticSearch versus MongoDB. It can be quite difficult to compare these two, but there's still a couple of things. So the data storage architecture, ElasticSearch does save its data outside a Lucene environment, where MongoDB uses memory map and maps on disk data and all that good stuff. So Elasticsearch does save CPU drain or disk issues, since it's an open source search engine. It's not using a disk really. Next is language support. This is kind of what I was saying in the strengths. Elasticsearch can use a variety of languages, but MongoDB uses C++ and only supports like four-ish languages unless you download community-made stuff. Whereas Elasticsearch, you don't need to download community-made stuff for the most part. The next thing is the use cases. Elasticsearch is for full text searches, where MongoDB uses CRUD operations more. It's more focused on like specific things, where Elasticsearch is for a broad or large amount of data. And full text searches, that's its main thing. The final thing is the backup recovery. Elasticsearch uses incremental snapshots, whereas MongoDB uses a Mongo dump tool or other snapshot. It can also use snapshots, but you'd have to download some extra stuff to do it. And also have to download cloud services and manage backups. That can manage backups. There's a variety of things that you can do to back up with MongoDB. So now Elastic versus Solr. I'm pretty sure that's how you say it. Solr is one of Elasticsearch's like main competitors, and since Elasticsearch is newer and more updated, it seems like it's becoming increasingly popular, where Solr is, at least what I've seen, is starting to slowly die out. really slowly though. But there's still some good differences between the two. Like the learning curve, Elasticsearch is a lot easier to learn, get set up, all that good stuff. Like it only takes one download or one command to get it working. Whereas Solr, you might need to download a couple of processes or files and stuff just to start it up. And then you'll have to learn how to do all the other stuff after that. Next thing is that Elasticsearch focuses on giving the user an easy way to search while being more efficient and grouping and all that stuff, while Solr focuses on a wide varieties of options to sort or search, not sort. So Elasticsearch is yet again more focused on full text searching, where Solr is for other kind of searching, but it can also use full text search. Solr, though, is more precise and reliable, where Elasticsearch, its data can be unreliable sometimes just based on it being a little bit newer, so it might be a little bit buggier. So Elastic versus OpenSearch. So OpenSearch is Amazon's response to Elasticsearch. When Elasticsearch thought it'd be a good idea to, make Amazon like use them, or if they wanted to use Elasticsearch, they had to be their partner and all that stuff. So Amazon didn't like that idea, and they decided they might as well just make their own and not have to deal with a third party. So OpenSearch is kind of new, not kind of new, it's pretty new, and it's still pretty buggy, like needs a lot of updates and all that stuff still. But OpenSearch is basically Elasticsearch. Other than that, there are some arguments that people say they copied the code basically, but its main thing is that OpenSearch uses Amazon's AWS. So instead of having to download it all and all that good stuff, you can just use the Amazon servers to use it. But again, it's a work in progress. It's fairly new, newer than Elasticsearch, so that means something. So it's going to be definitely buggy, and it still needs a lot of work.
So Kibana is the web interface for the data stored in Elasticsearch. It can kind of be seen as a cloud for your data, where the user can search, view, and then interact with the data stored in this cloud. Kibana allows for the user to monitor, manage, and secure an ElasticSearch instance via the web interface. And overall, Kibana is used as a data visualization and management tool for Elasticsearch that can be utilized to provide histograms, line graphs, pie charts, maps, and a bunch of different visualizations. So Kibana's interface allows users to put data into Elasticsearch indices and then create these visualizations. And overall, it's just important to note that data is so much easier to understand when you can actually visualize it.
Okay, so here we're going to talk a little bit about how to start Elasticsearch on the Elastic Cloud using Kibana. So first you're going to click on this link to get a free trial for Elasticsearch. You're going to log into Elastic Cloud, click on Create Deployment, select a solution, and name your deployment Homework 5. And then you're going to click Create Deployment and download the password given for the Elastic user in case you end up needing it later. And then how to launch Elasticsearch in Kibana. You're going to click on this link here to go to Kibana. You're going to log into your account, click on Kibana under quick link, which there's an image to show you where you're clicking. Then you're going to go to the main menu. There should be 3 bars in the top left corner, shown as the image depicted to the right. And then you're going to click on DevTools under Management to open the console and run the following example API request in the console to ensure that it is working and everything is set up. So I'm going to kind of run you through a bit of a trial here to show you how to do it. So you're going to click this link. Now you would click Start Free Trial. I already have an account, so I'm just going to log in. So after you have created a free trial and created your deployment, you would click here. I can't create another one, but you would create one. This is what your screen should look like. You'll have your deployment name, homework 5, status healthy, and you'll have this link here, which is where you're going to click Kibana under quick link. So it's going to take you to this homepage here. Now, to access Elasticsearch in Kibana, you're going to want to click on these 3 bars up here, scroll down to DevTools, and here we are. This opens you into the console for Kibana, and as you see, there's some sample text over here on the left, and on the right is where your results will show. And you'll learn a little bit more about this later in the video of how Elasticsearch works, but Kibana is a great tool to be able to visualize, as well as being able to access Elasticsearch through the cloud without having to actually download it to your computer. It's a bit of a quicker way to access it, and perfect for this project that we're doing here. So some examples, when you send a request, you're going to want to click on it, and then you're going to click the run button, and you will see in the right-hand column, your results will show up. So again, like if I wanted to send this request, I would click on this line and click run, and my results would show up in the right. And you'll learn more about what all this means later, but that is how you successfully set up Elasticsearch on Elastic Cloud through Kibana.
Hi guys, this is Jerry. So after Mehdi introduced us how to start using Elasticsearch on Elastic Cloud using Kibana, now I will guide you through the process of using Elasticsearch on terminal for local server and machines. Elastic needs Java 8 as an environment, so you probably want to make sure your machine has it to ensure Java home environment variable setting will be right. First, make sure you will have Homebrew installed on your local machine. Here will be a quick link for you to download and install the Homebrew if you don't have one yet on your local machine. So it's pretty straightforward, so you will get to there. And the first thing after you install Homebrew on your local machine, open up a terminal. You of course know where's the terminal at. So first, make sure the Homebrew is updated to the latest version by using the command brew update. Then we need to install the Elasticsearch brew install Elasticsearch to install Elasticsearch on our local machine from the terminal by using Homebrew. And after we successfully install it, we can start the Elasticsearch by type brew service start Elasticsearch. After we finish that, we successfully installed and run the Elasticsearch, but that's not it yet. We still need a Kibana. So Kibana is as known as a visualization and explorer tool for database. So we can type down the command brew install Kibana to download and install it. And after we got it, we can using the command bril service start kibana to make it running. After we finish all the installation process, we could open a web browser and type in the following address, localhost, 5601, which is a default address for the kibana. And additionally, for Windows users, you could download the Ubuntu application in the Windows shop for a Linux environment, or use the Elastic Cloud. You will find the detailed instruction from the previous page that introduced by Mehdi. And here we go. After we are all set and we get into the Elasticsearch from using Kibana part, I want to introduce some general conceptions. So the first one will be the node and the cluster. Elasticsearch is a distributed database. It allows multiple servers work together at the same time. Every server can operate many Elastic living examples. A single Elastic living example is called node. A group of nodes will become a cluster. Elastic has an interest index setting here. And I don't really have like that many covered in this slide, but I will introduce it. Elastic will search all fields. After the search is being handled, it will write in an inverted index. When you search for a data, it will directly search for the index. Therefore, index is at the very top of Elastic data management. Every database, which is the index name, must be written in lower cases. You can use the following command to search for indexes on the current node. And we're going ahead to introduce you the document to you guys. So a single data record in the index is actually called document. Many documents become an index. Document use JSON format. All documents in an index do not require the same stream, but the same stream will make the search efficient. So here's a simple code for you can see the user will be Tony, the title will be engineer, and the description will be database management. And a document can have groupings, which is called type. Type is a fictitious grouping to filter document. A simple example is under the weather index. It could be grouping by different cities, such as Boston, Dallas, or New York. Also, it can be grouping by different weathers, such as raining, snowing, or sunshine. Different types should have a similar schema. For example, ID can be a string in this group, but not a value in another group. This is the majority differences as a relation database comparing with the Elasticsearch database we have here. Different data types should become two index, but not a one index contains two types. Even though it can be written in that way, but I personally don't recommend it that way. So the command I post here lists every index's type here. And the fun fact, ElasticSearch version 6 only allowed one index has one type, but in the version 7 or above or later version will remove the type. So in this case, you can have like one index contains like many of them. So it will be like way convenient for using. And next part will be creating and deleting index. When we are creating an index, a new one, we could send a POT request to the server. The following example code here is to create an index that is named weather. The server will return a JSON object. The acknowledge means here, the acknowledge shows here means the request we did, the operation was successful. If we want to delete an index, we could send a delete request to the server, such like that. Elastic can also set like subspecify language for like subspecify words for like other languages such as Chinese, Spanish, but we won't introduce them here. Now we will take a look of the data operation part in the Elasticsearch. First of all will be the adding record. We can send a put request to a subspecify index type. We'll be adding a new record successfully. For example, if we send an accounts person, a new request to add a new staff record. The user will be Tony, and the title will be engineer, and the description will be database management. So we actually successfully send a put request to the server. And of course, the server will return a JSON with index, type, ID, and the version information, and etc. The following code is an example of the output here. So you can say the index will be accounts, type, person, the ID is 1, the version was 1, the result and the created with true means the operation was successful. So if you notice here, you will see the path of the account person 1. There's like a 1 here, but the 1 is actually a record's ID, but it doesn't have to be like a 1. It doesn't have to be like numbers. It could be like any kind of string such as A, B, C, D. So it's good to know. And the second part of data operation we'll talk about here will be search for a record. We can send a GET request to index type ID to see the record. For the command here, we can request a searching accounts person 1. This is record. The URL setting pretty true here, pretty true means asking the server to return a human readable format. So in this case, we can actually read the data that the server output to us. So if we want to delete the data, you will see the found. So if we would like to delete the data, you can send a delete request like the command gave here. And when we're uploading a data, if we're updating a data, we're still using the put request to send to the server. But in this case, we'll be not creating a new data. Instead of we just like updating the previous one. So from the example data here, the code is using the match search. We specify the term software to look for. Oh, here is the updating part. Sorry about that. But like, yeah, if we want to update the data, and from the example code here, we change the original code, Tony as an engineer, right, to the new one as we want description as database management and software engineering. So we use a put request to send the request to the server again. And for the output, we can see the total was 2 and successfully running, and created is false because we didn't actually create a new database, but we updated it. And finally, we're getting into data search part. So first, we are using get to request as from index type a search. And this one will actually output the whole thing, will be return all data from the server. And we actually introduced the GET request from the previous slides. And Elasticsearch has its own special search grammar. When we are using GET request, it needs data bodies. The data here actually use the match search. We specify the term software to look for. So the Elasticsearch will only return 10 results, but if we can configure the size, so if you want like a large output from like a huge database, you can configure the size, so it will output from the server how many ever the result you want to see. And the next part will be the search logic. So you can see here, the code here, we're actually searching for database and software. But the default mode, ElasticSearch will consider the default one as an OR relationship. The code here is example search for database or the system. So in this case, it's either database or a software contained in the database. And if we're going to use if we want to use the search to search for an AND relationship, when we search for multiple keywords, we have to use an interesting query called BOR query. So in the example on the right side here, we have to use a BOR query to the given code means we are searching for software and the database together. So all the output from the database will only be the terms that contains software and the database. And here, just simple example from the return outputs from the server. And this one is actually when you search for something. And this one is actually when you search for and like use the board query to search for like something else. The default one actually typed into Chinese, but those are actually like terms. So you will get to know there. And here are some supplemental information on ElasticSearch, and here are some links for it. And that will be it. And you will have definitely input an email and sign in for free 40 days trial to assess it. Will be pretty cool. And here are our some works cited. You can get the information that we get reference from. Thank you.